In this section, we're going to be looking at probabilities involving small populations. Now, I actually think that these tend to be a little bit easier because of the small population. It's a little bit easier to wrap your head around the situation and actually visualize what's going on. So we're going to start with a classic example. Imagine that you have a bag with 5 red, 3 blue, and 2 orange chips in it. First question that I want to answer, part A, what is the probability that the first chip that you draw is blue? So I'm imagining that I reach into this bag and I close my eyes and I'm just picking one out at random. Well, first it would help to imagine what the sample size is. Think about how many total outcomes there are. Well, if I look up here, I've got 5 red plus 3 blue plus 2 orange. There's 10 chips in total here. So there are 10 different total possibilities, 10 different total chips that I could draw from this bag. And if I want to talk about the probability that I draw a blue chip, well, out of those 10 different chips that I have, there are 3 of them that are blue. So 3 out of 10, or 0.3. And we have our probability. There we go. Let's look at part B here. Part B says, suppose that you did indeed pull a blue chip in the first draw if drawing with replacement. Now this is going to be really important that we're talking about with replacement here. What is the probability of drawing a blue chip in the second draw? So you're going to notice that we're going to talk about this distinction a lot between this page and the next page, with replacement versus without replacement, because this changes how we think about the scenario, and it changes the scenario quite a bit. So suppose that you did indeed pull a blue chip on the first draw. What this is telling me, this is my given right here. So pull a blue chip in the first draw, this is my given. So this is actually a conditional probability. So this is asking, okay, what is the probability if given that the first is blue? What is the probability of drawing a blue chip in the second draw? So, okay, if the first is blue, what's the probability that the second is also blue? Now, when we talk about with replacement, what that means is I take a chip out of the bag, I look at it, I note its color, and then I put it back into the bag. I can choose the same chip twice. So if you think about what's going on here, you've got 10 chips total, you take one out, there are 9 chips remaining. But before I take another one, I put that chip back. So that means that there's 10 in total. So I'm actually working with the exact same sample size that I did before. I put the same chip back. And even if the first one was blue, if I put it back, that means that there are still 3 blue chips left. So there's 3 out of 10, or simply just 0.3. So you're going to notice this pretty often here, that when we talk about sampling with replacement, it doesn't actually change the sample size when you go to the second or the third or the fourth draw, because the sample size remains exactly the same. Let's continue on here. Suppose you actually pulled an orange chip on the first draw. So it's telling me I pulled an orange chip on the first draw. So pulled an orange chip on the first draw. This is my given. We have another conditional probability here. So given that the first one was orange, if drawing again with replacement, so we're talking about with replacement, what is the probability of drawing a blue chip on the second draw? So if I know that the first one was orange, what's the probability that the second was blue once again? So again, it's with replacement. That is the most important part of this problem, in my opinion. So again, if I'm drawing with replacement, I take one out, and now I have 9 left. This one was orange, but then I put it back, and now there's 10 left for me to choose. So again, out of the 10 chips that are remaining in my bag, the first one, I didn't affect the blue chips at all. So if I go back and look, we said that there were 3 blue chips right here. So once again, 3 out of 10, or simply just 0.3. So what it appears to be, and this is going to help me answer my question in the next part, is if I look at the first draw right here, the first being blue, and here in part C we answered the first being orange, did that change the probability that the second chip was blue? Well, in this case, both of them were still just 0.3. We had 0.3 right here, and 0.3 right here. So in part D, it says if drawing with replacement, are the first and second draws independent? Remember, when we talk about independence, we're saying that the outcome of one event doesn't tell me anything about the outcome of the other. So in this case, yes, they are independent because we saw we had the same probability if the first one was blue versus the second one was orange. So the first draw does not affect the outcome of the second draw. So that's what I'm thinking about with independence. And you can look at these and tell that the probabilities are exactly the same. I want to know, hey, does the outcome of that first trial affect the outcome of the second trial? Move on to our last example here. It says part E. Again, we're drawing with replacement. What is the probability of drawing 2 blue chips in a row? So if we're drawing with replacement, we just said that they're independent. So we said, hey, if we're talking about independence, we said probability of A and B. If we have 2 independent events, we can think about it as probability of A times probability of B. I can just multiply those 2 probabilities together. So probability of A, we would say probability that the first is blue times the probability that the second is also blue. You don't necessarily need to write this part down, but I do think it's helpful in these first few problems. So the first being blue, we actually calculated that, and we can scroll back up to our answer for part A, or we can just work it out again and say, okay, well, there were 10 chips in total, 3 of them were blue, so 3 out of 10, I would multiply that together. And then for the second blue, again, we answered this question way back in part B, or you could say, well, again, I'm drawing with replacement, so that means the sample size does not change. There's still 10 total chips for me to choose from, and 3 of them have to be blue. And then I would just multiply my fraction straight across. 3 times 3 gives me 9. 10 times 10 gives me 100, so 9 over 100, or 0.09. So this would be my probability for this last part. So as you're working on the homework problems for this section, please make sure that you're reading very carefully and you're considering, are we drawing with replacement or are we drawing without replacement? Because as we'll see in the next video, it will make a difference in our answers.